Welcome my colleagues and my dear students. We are speaking today about the neural control of breathing, about the central mechanism of respiration. In order to respire normally, the process starts here from our brain. In the brain stem, the area of bones and the medulla, impulses descend in the spinal cord, then impulses are discharged via the respiratory nerves to reach the respiratory muscles, inducing the respiratory movements. Today we are focusing on the central mechanism, but also we will speak about the peripheral mechanism, which were discussed in video number 1 in the lectures of basics of respiration. We have respiratory centers that are present in the medulla and in the bones. There are two groups that are divided into 4 centers. Medullary centers that include inspiratory neurons, number 2 expiratory neurons, pontine centers which are amniotic center, and the pneumotaxic centers. Together they regulate the process of respiration. All of these centers lie inside the brainstem. Let us locate these centers. This is the medulla oblongata. This is the pons. We have 2 medullary centers. Dorsally, we have the dorsal respiratory group, or we call it inspiratory center. We have also ventral respiratory group. We call it also the expiratory centers. Together, they form the medullary part of the respiratory center. If we go higher, in the lower bones, we will find the important center, amniotic center, which is called the pacemaker of respiration. At the highest point of the bones, we will find the pneumotaxic center. Amniotic and pneumotaxic represents the pontine centers regulating the process of respiration. The amniotic and the pneumotaxic centers are not connected with respiratory muscles. They exert their regulatory effect on the medullary respiratory center. So, what is connected with respiratory muscles are the medullary centers, mainly the dorsal respiratory group, and they are regulated by the pontine centers. As we see here, this is the dorsal respiratory group and this is the ventral respiratory group. The dorsal respiratory group are responsible for the normal rhythm of respiration, and they have the property of the intrinsic periodic firing, so they can by themselves initiate the process of respiration. However, if they work alone, the process of respiration will be slow and irregular. When they are regulated by the medullary center, we get the normal, regular respiratory process. We have the amniotic center that is present in the medulla. This center is called pacemaker of respiration because it sends most of the time excitatory impulses to stimulate, to energize the dorsal respiratory group, the inspiratory center, under normal condition. So they call it the pacemaker of respiration because the original impulse start from the amniotic center under normal condition. However, this center tends to work all of the time, and this may be abnormal. If it is allowed to work most of the time, it will cause our respiration to be in the form of continuous inspiration, which is fatal. Its action is interrupted or regulated by the higher center, which is pneumotaxic center, which sends rhythmic inhibition for the amniotic center. So it allows it to work for a period of time, then it inhibits it, then allows it, then inhibits it. So the main regulator for the respiratory rate is the pneumotaxic center. Amniotic center is also inhibited by impulses from vagus nerve. So we have medullary centers, the dorsal respiratory group that are connected with the respiratory muscle, and they have the property of intrinsic periodic firing. However, under normal condition, they are regulated by impulses from the pontine centers. They are connected with respiratory muscles on both sides through the respiratory nerves, which are the phrenic nerve and the nerves supplying the external intercostal muscles. The expiratory neurons, which are called the ventral respiratory group, have no role during normal quiet breathing because, as we know, normal expiration is a passive process. However, they are so important during forced respiration while you are doing exercise only, not under normal condition. Both centers are reciprocally related. This is logic. As we know, most of the centers that do opposite functions have reciprocal relationship, so that when one of them is active, the other is inhibited. Pontine centers provide regulation for the medullary centers, and they generate the normal rhythm of respiration. Although the impulses from amniotic centers are energizing, are stimulating, they are converted from continuous response, which is dangerous, which are fatal. The action of amniotic center tends to be continuous, but this is not suitable because it will make our respiration a continuous inspiration. Its action, as we said, is interrupted by regulating impulses from two important sources. First, the pneumotaxic center. Second, the vagus nerve, and they form the normal rhythm of respiration. The pneumotaxic center, the highest center in regulation of the respiratory process, it is present at a higher level in the bones. It sends rhythmic inhibitory impulses for the amniotic center, converting its continuous activity into interrupted activity. Don't forget that it is responsible for determining the rate of respiration. So what about generation of respiration? It is simple title. The process of respiration starts from our brain, where the dorsal respiratory group send impulses through the spinal cord, then through the phrenic nerve and intercostal nerves. This impulses cause contraction in the diaphragm and external intercostal muscle. The chest increases in all dimensions, vertical by diaphragm, horizontal and anteroposterior by intercostal muscle. When the chest cavity increases, the pressure inside decreases to -2 mm mercury, so air rushes inside the lung. The process of inspiration is suppressed by impulses from three sources. First, the pneumotaxic center, which sends rhythmic inhibitory impulses to the amniotic center, so by turn the dorsal respiratory group is inhibited. Second, impulses from Herring-Brauer reflexes through vagus nerve. Third, impulses from the chest wall and the respiratory muscles. When the respiratory center is inhibited, the process of inspiration stops, so expiration starts. What about Herring-Brauer reflexes? These reflexes have a role in regulation of the respiratory process. However, they are important only during forced respiration, during exercise. Herring-Brauer reflexes have no role under normal, quiet breathing, only when the lung is much distended, and this occurs normally with exercise. We have two reflexes: Herring-Brauer inflation reflex that protects the lung against overinflation, and the Herring-Brauer deflation reflex. The first is Herring-Brauer inflation reflex. The stimulus is much inflation of the lung. The receptors are stretch receptors in the airways. The afferent is the vagus nerve. No afferents in the lung other than vagus nerve. Center is the inspiratory center. The response is that these impulses go to the inspiratory center, which is active at this moment and inhibits it. So the strong inspiration stops and the expiration starts. This reflex is so significant because it protected the lung against overinflation, which may cause rupture of the lung alveoli. Herring-Brauer deflation reflex stimulus is over deflation of the lung during forced expiration. Receptors are deflation receptors. Afferent is vagus. Center is the expiratory center. At this moment, the expiratory center is so active, so it is inhibited, so expiration stops and inspiration starts. This reflex is significant because it protected the lung collapse of the lung alveoli. To summarize this lecture, we have medullary respiratory centers and pontine centers. The medullary centers are the dorsal respiratory group and the ventral respiratory group. The pontine are the apneustic and the pneumotaxic. The dorsal respiratory group are responsible for the basic rhythm of respiration and they can work by themselves. They have the property of intrinsic periodic firing. However, they are regulated by the pontine centers to give us the normal respiration. The ventral respiratory groups are active only during forced expiration. Regarding the apneustic center, it has a continuous activity and it is called the pacemaker of respiration and it is responsible for energizing the dorsal respiratory group. Its activity is converted from continuous fetal activity into useful interrupted activity by the effect of pneumotaxic center, which determines the rate of respiration. Thank you and goodbye.